Hey guys, welcome back. So today, working on this Generac GP7500E. This one actually doesn't belong to me. It belongs to Jason, who's a local guy who buys and sells power equipment. Now, he actually got this generator as part of a package deal. He got 3 Generacs, none of which ran, and was told they should run with a bit of care. And he was able to get all 3 running. Unfortunately, only 2 of them made power. This one did not make any power. So he has about $200 in this machine as far as the purchase price goes, and he actually fixed it up before he realized it didn't make power. He bought a new battery, gave it a Craigslist paint job, cleaned up the tank, new wheels, and I believe it also has a new carburetor. So yeah, he's at this point at a $300 loss, and he's looking to at least break even on this. So to that end, he did locate a Generac GP7500 parts machine, which included a good Powerhead. So one way or another, this is going to make power again. Now, the Powerhead that's on here hasn't actually been tested, so it may potentially be good or be fixable. So what I'm going to do now is actually just check the basics real quick. We'll get some fuel connected to the engine, and I want to start it. Just validate that it is in fact not making power, and it is a good running engine. So let me get set up a little bit better and get going on this. The tank's actually clean and dry, so I'm not going to put any fuel in it. I'm just going to disconnect this line, and we'll get the test tank hooked up. So this is the setup. I've got a light plugged into each outlet. Each light is turned on, and the reason why I'm doing it separately like this is because each one of these is a separate leg on the generator, 120 volt leg, and these combine to make the 240 volts. So if it's a wiring issue or potentially an issue with the stator, you could get into a scenario where only one leg works. So this will tell us if we have any output from either leg. So before we start it, let's just check the oil. And we are on a slight hill, tilted away, so it might appear a little low. Yeah, it actually, I think it is a little bit low. Let me just add a bit to that. Yeah, it wasn't that low. I always find it odd when they put the start switch on the right front corner like it is here. The choke is kind of in the back left, so they couldn't be further apart. And when you're starting the machine, you really want to work both, or at least have them in reach. And it would have been a much better spot right there. Anyway, let's get this started and just validate that it's in fact not making any power. Confirmed. We have a good running engine, but a generator that makes absolutely no power. So let's get this inside. We'll get it up on the lift. I want to get the end cap off the generator so we can get a closer look at what's going on. You know, I just don't want to pull this off assuming it's bad. It could be something simple like bad brushes. So we'll run some tests. We'll figure out exactly where the failure is. And if it's terminal, we'll get this power head off and put the other one in its place. So far so good. The stator actually looks to be in pretty good shape. I don't see any burn marks, no melted copper, no signs of a meltdown, and the lacing is intact. If it had overheated, that lacing would be charred and broken, and I'm not seeing that. Granted, I can't see a whole lot. The AVR and the wiring, they're in the way, so let's get the AVR out. That'll give us a better look. And there's a zip tie right here. Make sure if you're putting one of these back together that you put a zip tie here, because these wires, if they're left loose, they can get sucked in and wrapped around the rotor, and that will completely destroy the power head. Yeah, and things are still looking good. Not seeing any evidence of a hot spot. So visually, there's no red flags here. Of course, we're still left with the fact that it doesn't make power. So really, to tell anything else, we're going to need a multimeter set to measure ohms to test each of the windings to see if there's an obvious problem here. So I'm going to start measuring the resistance through the brushes of the rotor. And a healthy rotor should be between 40 and 70 ohms. This one, I don't know the exact value, but I would expect to see something close. And in this case, we get nothing. So that is open circuit. Either we have a bad set of brushes or the rotor's bad. So let's get the brushes out, take a look at them. We can test them directly. And if those test good, then we know where the problem is. Aha. Look at that. I think we just got lucky on this one. These brushes, I don't think they're worn out. They look like they might have been broken right off. So this should be an easy fix. Let's just double check though. We'll get the leads on the slip rings, which is kind of tricky, and make sure we get some sort of reading here. And I get absolutely nothing. That is really disappointing. I thought for sure we found the issue. I mean, this is definitely an issue. Why they're broken and we have a bad rotor? I'm not sure. But I cannot get any reading on those slip rings. So unfortunately, the rotor is bad. And to change that out, we're going to have to get the stator off, obviously get the rotor off. The exhaust needs to come out because it's attached to the stator. And I think I'm actually going to start just by disconnecting all these wires, and we'll get the tank out of the way and just start peeling the layers off. In order to get the exhaust off, I need to remove this plate, which is covering the bolts for that exhaust system. So there is a bolt here, one there, one over there, and this should lift out of place. Just take note of where the governor spring is in case it falls off. This is an important part to controlling the engine speed. These bolts don't look too bad. I'm going to give it a little bit of PB Blaster just to help it out. So this wood here is just supporting this side of the engine, because once I remove the stator, the mounts on that side are gone, and the engine and the rotor are going to want to flop down, and you could damage the rotor. You know, in this case, it doesn't matter since this rotor already is damaged. You know, that said, you do want to have this kind of suspended so that there's nothing fighting you from sliding that stator off. So at this point, you know, we are pretty much free. We just got to remove these 4 bolts going around the stator, and then most likely I'll have to use a puller to separate the end housing from the ball bearing, and then the stator should just slide right out of place. Yeah, someone's definitely been in here before. I mean, the brushes, they didn't break themselves. Somebody did that, and I'm also noticing we are missing a stator bolt right here. There should be 4 of them, and I don't think that's gonna spin out on its own. So yeah, there's a little bit of funny business going on here. You know, potentially someone mixed and matched parts, or maybe they were trying to figure out what was wrong once it stopped making power. Just gonna use a little bit of PB Blaster to help free that bearing. And for the puller, you just want to make sure you don't put it right there where the brushes go, because that is the thinnest part. And in general, this breaks very easy. These pieces are very thin, so you don't want to torque down on this very hard, or you will break the end housing. I've done it several times, even knowing that it's delicate. It's very easy to break. And it is coming out. There's a lot of damage actually on the stator. I wasn't expecting that. We have broken lacing, bunch of broken wires, and although the wire in the stator looks to be copper, it's actually not. It's most likely aluminum. You can kind of see it right there. And if you look up here, there's a lot more damage where the bare wire is exposed. And yeah, a lot of broken lacing, a lot of broken wires. So unfortunately, the stator is also shot. And really the only thing I can think of that would cause that is something caught up in the rotor fan and just spun around in here, chopping up the stator. So let's take a closer look at the rotor. And there is no fan. I mean, there's the remains of a fan right there, but that should be a full-sized fan. You know, if you look at any of these rotors, you can see what the fan is supposed to look like. That's what draws air through the power head to keep it cool. And without a fan, it would have overheated and melted down regardless. But I think it didn't even have a chance. Someone started it, the fan exploded, and caused a lot of damage. You can see a wire right there sticking up, and a bunch of wires right there. So, yeah, I would say someone's definitely been in here because the pieces of the fan, they're gone. Like, there's no way for those pieces to get out unless someone either removed the stator, or more likely I'd say they removed this vent cover right here, and they might have been able to pluck them out right there. So yeah, someone knew this power head was bad, and yeah, they sold it as a good generator. So yeah, that's unfortunate. You know, I was hoping I'd at least have a good stator out of this, and instead both are trash. So let's finish the job. Let's get this rotor bolt out. We'll get the rotor uninstalled, and then we can put the good used power head in its place. So I'm actually going to do the easy thing here to get this rotor off. Now, you probably don't want to do this on a good rotor because you could cause damage to it. This one, it's already damaged, so I'm not too concerned. So what I'm doing here is just turning the bolt in most of the way, and then I'm going to use a 4-pound hammer, hit the end of the bolt a few times, and it should pop the rotor off the tapered shaft. You know, there is a risk I could bend the bolt, so I'm going to check it every few hits, just make sure it still spins, because I don't want to pretzel that bolt inside the rotor, and then we have a bigger problem to deal with. And there we go. And there's a better look at the carnage. Bunch of broken wires, we got broken plastic, and surprisingly the fan was metal. You know, I would expect a plastic fan to potentially fail. You know, this bolt here actually looks like it's backed out a little, but I don't think that's what caused the issue. You know, I'm not sure if there was a nest in there and someone just tried starting it. You know, maybe there was some ice, some snow, or maybe a defect and this thing just shredded itself. You know, whatever it was, you know, I guess we'll never know. And I've already tested this rotor. It is good, as well as the stator. So I'm going to clean the slip rings while we have easy access, and then I'm going to pop the recoil off to get a wrench on it to hold the crankshaft still so we can torque down on this bolt. Should be torqued to about 30 foot-pounds. I'm just using a piece of Scotch-Brite. Makes quick work of it. Just be careful of the wire. There's one on each side, which connects the rotor wire to the slip rings. You know, that is actually a common point of failure on rotors. Usually they don't melt down. It's just a broken wire usually from spinning at 3600 RPM. And there's not a lot of support for this wire, so it does vibrate, and over time it can fail. That should be good. There we go. This wire just runs over to the battery. It is the negative, which connects basically to the entire engine and stator. Before I get too carried away, I'm going to remove the spark plug so that the engine has no compression. I want to pull the engine over, make sure it turns freely, that I don't hear any scraping between the rotor and the stator, and even worse, you know, if the engine binds due to a misaligned stator. You want to know that before you try to start the engine, because if you start it and those two are making contact, then they will destroy each other pretty quickly. Perfect. So I think it's safe to reconnect the wiring. Now, you just don't want to reconnect it without understanding what wires do what. You know, these are color-coded and they happen to match, but you can't rely on the colors. Sometimes the colors are very poor as far as their choice. You know, I've seen red wires that are neutral, white wires that are hot, so don't trust the wire color. You know, instead, get the multimeter out, set it to ohms, and find out which is leg 1 and which is leg 2, because 2 of these wires are connected together, and then the other set are also connected together. So you want to make sure you understand the wires that are connected together. So in this case, there's no connection, no connection, and we have a connection, 0.3 ohms between these 2 wires. So that is one leg on the generator. So that would feed one of the 120 volt outlets. So if we check the other 2 wires in the middle here, we should get a similar reading. 0.3 ohms, 0.2, even better. Let's just double check this one, make sure we can get a 0.2, and we do. So they are matched. So now we have some information. We know these 2 are one of the legs, and those 2 are the other. And based on the coloring, you know, the whites, I would say, are the neutral. And we have similar colors here. So, you know, most likely this connects just like that. But again, you want to be sure. So the neutrals, which I'm assuming are the white, they should be connected together up in the control panel. So let's just double check that. And they are. We have a direct connection, and most likely the green is also connected to neutral if this is a bonded generator, which it is. So these 2 white and the green, they're all connected together in the control panel. And that's important because we just identified these 2 wires as being one leg and the outer 2 as the other leg. And you don't want to put 2 wires that are connected together in the control panel on the same leg, because then you're going to short out your generator. So they have to be on separate legs. You know, if nothing else, do not create a short. The ground wire just goes right there. And then we have leg 1 and leg 2 right there. So let's get those connected. We do have issues here. If you've seen some of my other videos, you probably know what I'm about to say. You know, we have washers on the back. There should be washers on the front as well as lock washers. Those are missing. And more importantly, if you look at this insulation right here, it actually comes down on the ring terminal. So when you put these 2 wires together and you tighten down, it's going to form a little spacer, and you're not going to get full contact. And that might cause issues with the power output. So these ideally would be slid up, but I don't think that's going to happen. So I'm going to get a razor blade, just kind of cut away so that we see the full ring terminal on all of these. And then we can attach everything together. There's really no excuse for this either. I mean, this is common. You know, if you do any electrical work, you don't want to have insulation on the connection preventing a good connection. I mean, look at that. Anyway, you get the idea. I'm just going to trim this back on all these connectors, and then we can connect everything together. It's interesting too. This is very similar to the Briggs, where we had the insulation that came down too far and the oversized terminals. You know, these studs, they're not that big. And when you put this on, yeah, it's not a great fit. This is a lot better. You know, how small this ring fits on there. So it's interesting that they chose to use such a large size. Doesn't really make any sense. The Honda clone brushes, they only use one bolt on the left side. I get a lot of comments on that I forgot to put a bolt in. On the right side, there is a hole, but there's a piece of aluminum sticking through just as a locator to keep the brushes in the right position and also to prevent them from moving. But all these bolts in here, they're very easy to strip out too. Just use hand tools and snug them up. Use power tools, you're going to strip these all out. So get the AVR plugged in next. This connector you can't plug in the wrong way. There are 4 wires on it. The blue ones actually provide power to the AVR. The other 2 wires are the sense. That's what the AVR uses to monitor the output and adjust the voltage to the brushes accordingly to maintain the 120 volts. And these wires, they feed power through the brushes. The red one is positive, and it's usually labeled. You want to make sure that goes on the left. If you get it backwards, you're not going to damage anything, but your generator also most likely will not power up. And that's it. Theoretically, this should make power the next time it runs. Let's try it again real quick. There's still fuel in the carburetor from earlier. So I plugged in a light, it's turned on. That's in one of the legs. On the other leg, we have the kilowatt. So let's start it, and hopefully that light comes on. Very nice. We've got power just over 123 volts. So we don't need to make any adjustments down here. The AVR is actually running it pretty well. So I say we finish this up, get the end cover on, and then I want to roll this outside. We'll start it again with the fuel supply connected, and I want to bring up the engine speed. The no-load speed should be around 61.5 Hertz, and we were at just below 57. So that is an easy fix. We can just drive this screw in, which will actuate this arm, increasing the spring tension. So once we get to 61.5 Hertz, we'll put a load on and just make sure there are no surprises. Kind of hard to show you. This wire is in the way, but there is a bolt behind there that's designed to hold a zip tie like this, that has this through hole for the bolt. You know, if you don't have a zip tie like that, you can just use a regular one and zip tie those two together just to take out the slack. And most likely, you'll be fine. You know, I always had my doubts as far as whether this was really needed. And then I picked up an almost brand new storm responder that did not have the zip tie from the factory. And that generator made it about 20 hours before the wires got sucked in and completely destroyed the Powerhead. And it's actually easiest if you use one zip tie like this, just a standard zip tie, and then the other kind just to loop into that to kind of hold it out of the way. Let's just double check the oil since we're on a fairly level surface. Yeah, we got plenty of oil and it's fairly clean. So I think it was changed recently. And we have a filter which is in good shape. So I think we're ready. Let's get this outside and see what it can do. All right, pretty much ready to go here. I've got 6,000 watts of load on standby. The plan is to get the engine started, we'll adjust the no-load speed closer to 61.5 Hertz. We'll double check the voltage and the distortion without a load. You know, currently the amp probe is set to measure voltage, and I've got a probe in each leg. So we should see 240 volts out if I wired everything correctly. Then I'll switch it over to measure the distortion. We'll see what that's at without a load, and then we'll load it up. See how the numbers change, and make sure the engine has no issues. I had to shut it down. The engine is definitely down on horsepower. It had no issues pulling 3,000 watts. It was holding right at 60 Hertz. I then tried to double it to 6,000 watts and it couldn't do it. So I took that load back off. I tried 5,000 and same thing. It could not do it. So I would say we're missing quite a few horsepower. I would say at least 6 horsepower. So yeah, that's a little surprising because when I pull the engine over, there's essentially no leak down. So I don't think we have an issue with the valves sealing. Really the only thing it can be, in my mind, is the carburetor or potentially a valve adjustment. So let's get the valve cover off. We'll take a quick look at that, see if those valves are misadjusted. And if they're not, then maybe we're dealing with the carb issue. I mean, this carb does look brand new. But yeah, it's got to be one of those things. I can't imagine it being anything else. So let's take a look at those valves. Let's check the exhaust valve. Right now the intake is open. And I did not look up the exact specs on this. Usually this engine though, it's 8,000ths on the exhaust. Some are a little tighter, up to 6,000ths, and the 8 is a little loose. Let's check the 9. And the 9's pretty tight, so I think that's fine. Usually this is 8,000ths plus or minus about 1,000th. Let's check the intake. That should be 6,000ths, usually, plus or minus 1,000th. So we'll start with the 6. Actually, we've got to rotate the engine first. You know, I think we might have bigger problems here. Yeah, that valve is set properly. The thing I noticed, though, is the intake didn't seem like it opened that much, so we might have a worn-out camshaft on this engine. Let me rotate it again. We'll just keep an eye on that exhaust valve, because it should be opening further than that. So the exhaust valve, it's open right now as far as it goes, and I can hardly even tell that it's open. I'm going to keep rotating the engine. You can just see how it compares to the intake. Now the intake's open all the way as well. And it still doesn't look great, but it is better than the exhaust. So yeah, I am thinking we might have an issue with the camshaft. So I'm going to pull the spark plug out so there's no compression fighting me. And I'm going to pull the engine over until the intake's fully open. And I'll try to measure how far the spring is compressed. And then I'll do the same on the exhaust. So now the plug's out. I'm just going to rotate it again until one of the valves is fully open, which looks to be the exhaust. So it's 30 millimeters, the length of that spring. Let's rotate it until the intake's fully open, and we'll do the same check. 27.7. So the intake, it is opening further, which, yeah, it's only about 3 millimeters further. Is that enough? Might be. You know what? I have another Generac, not exactly the same model, but let's pull the valve cover off of that and see what kind of travel we have on these valves. So we'll take a look at this one. This is only a GP7500. You know, the engine, though, it's about the same as far as the horsepower goes. You know, and I would expect the camshafts are most likely identical, so we should have the same valve travel. And I'm just going to rotate the engine like the other one. I can already see a big difference in the amount of travel that valve has, the exhaust valve. Yeah, so this one, the valve when it's compressed is 23.5 millimeters, and on the other generator, it was 30. So that's a difference of about 7 millimeters, or that distance. That's pretty significant. Let's just double check the intake on this one. On the other generator we just tested, the spring was 27 millimeters in height when fully compressed. In this one we're at 22. So yeah, unfortunately, that generator has a worn out camshaft. All I can say is you can't win them all. You know, this one, I thought we were going to make a lemon into lemonade, and unfortunately, it's now a bigger lemon. You know, Jason had $300 into this. It didn't work. He was hoping to climb out of the hole by sinking another $200 in to get a good Powerhead. And at that point, he could at least break even, if not make a little bit of money. You know, instead, we have a worn out camshaft. And those valves, they just can't open enough to let the air and fuel in and the exhaust out. 8 millimeters doesn't sound like a lot, but when you consider the travel of those valves isn't a lot, maybe 10 millimeters in total, and 8, that's a significant amount for those valves to not be opening. So this engine, unfortunately, it needs a new camshaft, and I don't have a good camshaft to put into it. And even if I did, you know, I'm not sure I would do it in this video. That is a whole other video. It's going to require another teardown to do. So for now, I think I'm done. So I hope this video helps someone. Thanks for watching. A little bit of bonus footage here. I want to drop the oil, just see how bad it looks, you know, if there's any sparkly bits in there. And once the oil's out, we'll use the Borescope, try to get it in there and get a look at the lobes. That's not good. I don't know if you can hear that. It almost sounds like rocks hitting the pan. Oh yeah. Not sure how well the microphone picked up the sound, but when I first pulled that bolt out, I heard a lot of noise hitting the pan. Little bits of something. And there's one of the bits right there. Let me see if I can get a few more out. I mean, it feels like gravel. Yeah, I don't think it is metallic. Yeah, those pieces are just, I think, sticking due to the oil film. This is a pretty strong magnet. It should be picking all this up if it was metallic. So yeah, I guess I'm not sure what that is. I don't think it's part of the camshaft. And I would say whatever that is, it's just oil contamination. And that is what wore down the camshaft. And most likely, we're not just dealing with the camshaft issue. If the block is full of that junk, then most likely the ball bearings are on their way out, as well as the connecting rods. So yeah, this engine might not be a good candidate for a rebuild. Anyway, let's get the Borescope out and see what we can see. All right, let's take a look and see what we can see. And I see a bunch of rust. That is the crankshaft and a bunch of rust on the counterweights. The gears look a little bit worn, a little bit corroded. You can see the camshaft kind of on the right center of your screen. That is actually the exhaust lobe. And I think that's the pointy part of the lobe facing us, at least what's left of it. Let's rotate the engine. Yeah, not much left of that lobe. It's pretty rounded out. Right there is the peak, and that is not much. So, yeah, unfortunately, the camshaft issue is really just a symptom of a bigger problem. And I think that this engine was most likely underwater, and it caused a lot of rust on the gears, on the crankshaft, and all that debris floating around caused wear on the camshaft, wear on the gears. I'm sure the ball bearings are also worn out. So, yeah, unfortunately, this engine, it is not a rebuild candidate. It is a parts machine, which is too bad because I don't have any spare engines at the moment. So this generator is definitely going to get pushed in the corner until I can locate a replacement engine, which will happen. I mean, it's much more common to have a powerhead fail than one of these engines. So it's just a matter of time. I'm sure you'll see this generator again. But for now, I think I'm done.